Hello everyone, myself Tejas Jadhav. I am from Department of Physics, Savitribai Phule Pune University, Pune, India. Today's my poster presentation topic is structural and ferrotic properties of BaTiO3 and K0.5, Ne0.5, NbO3 lead-free piezoelectric ceramics. First the ferrotic material. So ferrotic material are those materials which shows the spontaneous polarization, and this polarization is reversible under the application of electric field. So in first side we can see there is a randomly oriented dipoles. So net polarization is 0, but when we apply the electric field, this dipoles try to align in direction of electric field. So another diagram is the polarization versus electric field. So in this we can see there is a p hysteresis loop for it shows the ferrotic nature of material. Next diagram is the dielectric constant versus temperature. So in this diagram we can see there is a higher maxima point, so peak. At that peak we can calculate the Curie temperature for ferrotic material and higher dielectric constant for ferrotic material also. But when you increase the temperature above the Curie temperature, then ferrotic material become a paraelectric material. So objectives are synthesis of pure phase of BaTiO3 and K0.5, Na0.5, NbO3 by solid state reaction method, to analyze the structural property with XRD pattern, to study the surface morphology of sinter BT and KN ceramic, to study the p hysteresis loop of synthesized sample. The orientation of problem. So PbZrTiO3 is called PZT. It shows the good piezoelectric and ferrotic material. It shows the good piezoelectric and ferrotic properties. So its material is good in application of electronic device and in automobile also. But the main thing is that PZT contains lead oxide, and lead oxide are very toxic. So in 2003, European Union banned to use the lead based materials. So researchers focused to develop the new materials having properties comparable to PZT. So we know the BaTiO3 also shows good periodic properties. So here we also mention the textures piezoelectric ceramic. So texture is a method is useful to enhance the piezoelectric and ferrotic properties of ordinary polycrystalline material. So after texturing, the grain or growth of polycrystalline material. So we can see there is a D3 versus texturing degree. So after texturing, the random polycrystalline material become a single crystalline material. So this is a cost effective technique is useful to enhance the piezoelectric and ferrotic properties of material. So in which templates are used to enhance or to grow the grain of polycrystalline material. So templates are the particles in which the crystal axis is aligned in particular direction. So we also studied the ferrotic and piezoelectric properties of BaTiO3, modified BaTiO3 unit cell. So there is we mentioned the XRD of BaTiO3 shows the pure phase of BaTiO3. We also got the Curie temperature at 125 degrees Celsius for BaTiO3, modified BaTiO3, and also the polarization versus electric field. It shows the ferrotic nature of BaTiO3. Also we studied the J versus electric field and also studied the strain versus electric field graph. In this we can see there is a sprout shape, and in this shape we can see there is a piezoelectric nature of BaTiO3, and also we study the electrostatic coefficient of BaTiO3 ceramics. We also synthesized the K0.5 and K0.5 Na0.5 NbO3 at 1080 degrees Celsius for 4 hours, and we also studied the polarization versus electric field. So KNN shows the ferrotic nature. There is a p hysteresis slope shows the ferrotic nature of KNN. We also synthesize the NaNbO3 at 975 degrees Celsius for 6 hours. So this is we synthesize the NaNbO3 template. So by using this template we can texture the KNN ceramic. So after texturing, that KNN ceramics become a like a ordinary KNN polycrystalline material become a single crystal material. So maybe after that it show the good piezoelectric and ferrotic properties. So it's good for application in electronics device and in automobile automobiles also. Here we also synthesize Bi4Ti3O12. This is a precursor. So the next step of our research is to synthesize the BIT template. So after using this precursor, we want to synthesize BIT template, and we want to texture the BT. So this precursor is very useful. We also study the polarization versus electric field. So there we study the P hysteresis loop. Temperature depends on p hysteresis loop. So here we can easily see that there is a 30 degrees Celsius, 60 degrees Celsius, 90 degrees Celsius, and up to 120 degrees Celsius. The BT shows the p hysteresis loop or ferrotic nature, but after that 120 degrees Celsius, the tetragonal phase of BaTiO3 become a cubic phase. So after that it's not shows the ferritic proper behavior. So after that there is a linear behavior of polarization versus electric field at 125 degrees Celsius. We can easily see that. So after that 120 degrees Celsius, BaTiO3 unit cell convert into cubic unit cell. There is a PR versus temperature. So remaining polarization also decrease when we increase the temperature. So conclusion, all the beta and KNN lead free piezoelectric ceramics were prepared by solid state reaction method. The XRD studies confirm the formation of pure tetragonal and rhombohedral phase of KNN respectively. Typical ferroelectric nature has been observed for all the samples. The SEM images shows the dense microstructure with average grain size for BaTiO3 is larger than the KNN as it was sintered at higher temperature. Acknowledgement. Thank you for UGC DACSR for providing the funding agency, and thank to all of you for your kind attention.